Hello, this is Kyle again. We've talked about all the aspects of planning and designing a user interface, and now we need to make it work. Note that this task will rely very heavily on functions. So if you don't have a good grasp on how to write a function definition, you should go back and review our content on the subject of functions from a week or two ago, whenever that was. Thinking back to our 15-step plan that we talked about earlier in this video series, really in this video we're talking about step 12. We're talking about translating any pseudocode or flowchart, any planning documents, into code. We've already got a designed and tested user interface, but we need to make the buttons work. For the example we've been doing, there only really is 2 pieces of functionality, and we might add more in the course of this program. The debugging and testing is important. The distribution, obviously, may be a little bit beyond the scope of this course. But debugging and testing is important. It might be covered a little bit incidentally. We really are focusing on coding the functionality in this video. So here I've got my future value code file, and there's lots of things we need to add here. We need to add function definitions that will define the behaviors of the different things that happen in the run of this program. But in order to do that, specifically for our exit button, we need to introduce a piece of functionality that will allow us to exit. And there are multiple ways to do this, but I'm going to choose to do it this way using an import called sys, which is short for system. And there are other ways to do it. And so sys is being imported for the sake of making our exit functionality really easy. And then we're going to get to creating our functions. Usually in a Python file, either your functions will be in a separate file, which is sort of more like what a professional coder would do, but we're an intro to programming, we're not fussing about it too much. Or you would do it before the labels and other features of your tkinter interface are defined. So I'm going to define the functions up front, just like this. Define functions. And here's going to be my first function. It's going to be the calculate future value function. I'm going to change the parameter list here to have a function that's designed to be discarded. It's a little bit weird, and the reason I'm doing it is a little bit hard to explain too. But essentially what this function is going to be doing is when the button is clicked, the calculate value button is clicked, it's going to figure out the value and populate the form with it. And when an event handler is called, a function designed to handle events, it usually passes in what event is taking place, and tkinter sort of hides that. But in order to get this function working nicely as an event handler that we can call, as a function we could call from anywhere, and also to work with hotkeys, it's a really good idea to set it up so that the function will have a parameter called an event that eventually that is set to nothing. Otherwise, we need to pass in parameters that we don't actually need, and this way just looks a little neater. Even though this is hard to explain, it is valuable. So now I'm going to have the input part of my function. This is going to look a lot like input functions we've done earlier in the semester. So I'm going to check for each of my fields, and I'm going to kind of clump them together for the sake of convenient coding. You know, whether this is a good idea or not depends on your requirements. What I've done here is I've set valid investment, a new variable named valid investment, equal to entry investment, the entry field on my form, its get property casted to a float. So what we're doing is we're getting the value from this entry control, this text entry control. We're getting its value, and we're going to cast that to a float. And it's within a try block, so there will be something we can do in the event that it fails. We're going to do the exact same thing here with both the rate and the number of years. Now I want to check the ranges. I don't have a lot of requirements for the range of these values, but I do need to make sure that they're all positive. You can't invest a negative amount of money or invest money for a negative amount of time, certainly. Although it probably seems like it sometimes. I don't have a lot of room for my error messages, so validating these all at once actually carries a little bit of benefit for me, just in terms of my user interface design, although that's not really important here. So here's my validation, and I'm going to start my calculation now. This was discussed earlier, avoiding the numeric literals, using my uppercase for my constant because PEP8 requires it, and I'm going to start my processing at this stage, starting with giving future value a default value. Now I need to figure out the number of months and the interest rate to use. This was discussed earlier in the planning video. And now I'm going to use iteration to do the calculation for this. And this is because any money you've already accumulated gets reinvested, and so this happens through iteration. Here I'm going to use a formatting code to output this really nicely as a currency value. It's not always an easy thing to do. In this case, I want it to have a dollar sign, and I want it to have 2 decimal places. So I'm going to use a formatting code to do that. So I'm going to say that the text property of the output box becomes equal to, and I'm going to use my formatting code here to say it's going to be a string, it's going to have a comma, it's going to have 2 decimal places. And now I'm getting into the else statements from this if, and then the except statement from this try. So 2 different validation statements. The first one is for the event that any of the values are less than 0. So it's going to look like this. And that should explain things well enough. At this point, my first function, calculate future value, is done. And everything within the scope of this function is going to happen every time that button is clicked. It is not past a bunch of parameters, but it does operate directly on a whole bunch of entry fields and even labels for the purpose of output. The next function I'm going to code is the exit function, and thankfully, this is much easier. I have to tell you, frankly, I like to do exit functions first usually, because then I feel like I've got something done. So go ahead and copy me on that if you like. Make an exit function so that you can have half of your event handlers done, for example. And this is just going to call sys.exit. Exit is a functionality in that sys import that we included up here, and it's just going to close the application as soon as it's activated. So we're done our design, we're done 2 functions. Maybe all the functions we'll need, but we'll see. And now we have to add them into the functionality. We have to add them as commands for our buttons. And so that works just like this. In the definition of the button, we say what command it's going to execute. In this case, it might be command equals calculate future value. And in the event of in the case of our exit button, it's going to be command equals close window. And now we have commands on our buttons, and those should be operable. Let's test it out. So here we go. We're going to run it. I'm going to run it without debugging. And if I put in some expected values, like, oh, I don't, maybe I should use my desk check, right? Where's that? Oh, here it is. Okay, and so I'll put in the expected values I have here. So 10, and my annual interest rate is 0, and my number of years is 1. Wait, that's not right. 0? Yeah, I want 0.12. It just didn't show up because of the rounding. Here we go. Oh, all input must be numeric. And so maybe this is a good time for debugging, and I did say we would talk through the other steps perhaps incidentally. Oh, I should have used my exit button. I'll do that soon. But what we're going to find is that there is an issue in here, and it's going to be inside the method. And so what you can do is you can do a little bit of debugging. You can try things out. I must admit there's an error, and it's a bit of a subtle error. If I were to, say, put a breakpoint here, and we haven't exactly talked about breakpoints much, but if you want to see what's happening with the program, we can put in debugging, we can put in whatever values we want. And this allows us to see what the values in the run of the program are. We can see the part where it crashes. Let's see. Oh, line 49 is exactly where it tells us we have invalid input. And so I can show you this error. It happens that what's happening is it's trying to count up to total months, but I've accidentally introduced a floating point variable here. So I need to actually cast this to an integer no matter what it is. So let's do that. Cast that to an integer. And then I'll get my desk check out again, and we'll run it again. And we'll put in our test values. So 10, 0.12, and 1. Nice predictable values. My value is much too high. And in fact, considering that this is 1 year of investment, we know that something's gone wrong. There's a few things you can do to figure out what this problem is, but you kind of know that the value that's calculating incorrectly is the actual line of code that is determining the future value, which is right here inside the for loop. This is the part where it's determined iteratively. And you might be able to use your keen eye to spot the error right away. Do you see it? It's a little bit subtle, but if you were following the requirements really closely, you might spot it. It's actually this. If I add 1 plus the rate every time, an extra $1 is being added every time, and the multiplication isn't happening. So over very small investment values like the ones I'm using, the value is going to get a little higher than it should. But on a big investment, it would be much lower than it should. This this addition here should actually be a multiplication. And so if I test this again, put in some test values, maybe I should enter something incorrect, like Jeff. Oh, all input must be numeric. -4. All input must be positive. Okay, something went wrong here a little bit with the formatting. And if I enter something valid, well, let's go with the 10, the 0.12, and the 1. Calculate. Oh, look at that. It matches the test value exactly. It matches my desk check. So in a way, that's part of the testing and part of the debugging. Although it wasn't really syntax errors. I guess it was partly syntax errors. It was syntax errors that were accounted for by our validation. But we got our test value. This is working. Of course, we're not done. We're not quite done. Even for a simple demo like this. And there's a few things I would add, perhaps. But there's more to do. We would like to have some hotkey functionality. And that's not too hard to do. So if we want to add that in, we can add it. I like to do it at the bottom, but technically you can do it anywhere once it's been defined. You can add binding to the window to run certain commands based on key presses, like so. I can do this. Add hotkey support, hotkey or access keys for the main buttons. Well, there's really only 2 buttons. So window.bind, and I can say exactly what key press. I'm going to do Alt-C. And I'm going to make that do calculate future value. So if I hit this Alt-C, I'll expect that button to go, which is in line with my plans. And then I'll do similar for my exit button, but I want the hotkey to be on X. Oh, just like this. The formatting is somewhat important here. And I want this to be the exit window or whatever it is. What did I call that? Close window. So this one you don't say command equal or anything, and this is the point where if we didn't have that event thing set to none, this wouldn't work quite the same. We can also set a default behavior for some other keys, like this. Oh, it's actually return. Return for basically the enter functionality, the default behavior of the application. So let's test this out. We should be able to run this with our keyboard only now pretty nicely. Oops, it's Alt-C. It's recognizing our keyboard symbols here. Okay. 12, 12, 12. I don't even know what that equals. Oh, it's a gigantic amount. That seems like maybe a very good investment, but we don't usually get interest rates like that. Okay. So if I change these values and hit enter, it changes. If I change these values again and hit Alt-C, hitting Alt-C doesn't work, and it's a bit of a strange behavior, but observe. If I hit Alt-Shift-C, it does work. And so what's happened here is it's because I've put in my hotkey using a capital C, believe it or not. And if I just change this to a lowercase c and lowercase x, I'll see those behave without the need for the shift key. So if I go 1, 3, 2, and then Alt-C, it calculates, Alt-X, it closes. So now I have hotkeys, and that wasn't too hard at all. The one thing I was considering adding was some close functionality, which does tell you a little bit more about how to interact with controls, but this video is pretty long, so I think I'll add it into a small addendum. Before that small addendum, this video was creating functions and setting them up to handle events. At this point, it would be nice if you were comfortable with the command property of a tkinter button and how you can set it equal to a function and have it run that function when it's clicked. And also, maybe you have observed what the window.bind method is for.